Hi, let's solve this question together. This is the question from question 4 in the lecture 4. This is about contact surfaces. This is a 2D question and we will use our choice scalar analysis for it. Now, let's reinterpret a little bit about what the question gives us. The question gives us a wall and a floor. The wall is smooth. When we say smooth, it means there's no friction. Friction is assumed to be zero, negligible. If it's rough, it means that the friction is significant. Usually, we have to work out what is the coefficient of friction. In this case, it gives us static coefficient of friction of 0.2. Now, the total length of the stick is 70 centimeters with the weight of 20 kilonewton and is equally distributed. What does it mean? It means that the weight 20 kilonewton is falling on the middle of the stick. How we actually get to that will be in the next lecture. But anyway, let's solve this. It is leaning on this wall with the angle of 60 degrees to the floor. Now the question is, can in this condition is in equilibrium? Can it be in equilibrium? Right? Now this is the same thing. When we talk about equilibrium, this is the same thing of while talking about resultant forces and resultant moment with different specific target though. This is not to calculate what is the summation of force, what is the summation of moment, because if it's in equilibrium, we already know the summation of force in all direction, in any direction, must be zero. The summation of moment in about any axis, about any point, must be zero. Therefore, the question changes into whether the force system that it can provide is in equilibrium. Let's see. Or basically, can the whole force system sum all up? Force becomes zero and moment becomes zero. Right? So that is the target of our calculation at this time. So let's see. When we talk about calculating forces and moment, the next thing we think about is free body diagram. So let's do the free body diagram then. Right? Now, the stick itself, this is not the free body diagram. To draw the free body diagram, it has to be removed out of the environment, so it cannot be drawn on this. Right? Therefore, draw it apart. Then we start off with the body. In this case, we talk about a stick. Now, if this one here to the horizon, the floor, this is 60 degrees, correct? According to the question. Now, let's talk about the force first then, right? On the wall, we have a contact surface here. There's no glue, nothing stuck in it, just contact. It's smooth, therefore there's no friction. There's only one force then. It's the normal force. Normal force is 90 degrees to contact. In this case, the wall is that way. The stick is leaning on it that way. So the force is actually 90 degrees, not to the contact, not to the stick, but to the wall. So we have the force coming out this way. Correct? Then we also on the floor here we have because it's a rough surface, we have both forces, the normal force and the friction. Again, this one here, the normal is 90 degrees to the floor. Therefore, the floor is that way, normal is this way. Let's call that point 1. And the reaction from the wall is N1. Okay? Then, that one, let's call it point 2. And the force here then become N2. Normal usually use N. And then, of course, we have a friction. Now, if we imagine, how would it move? How would this stick move? It would slide down this way and rotate like that, correct? Now, friction has two rules. One, it has to be parallel to the contact surface, so it's on this line, right? 2, it must resist the movement. If it's going to slide this way, meaning at this bottom here is trying to slide to the right-hand side, therefore friction have to push back to the left-hand side. So in that case, it is this way. F2. Okay? So Since we're going to take the moment, we know that we're going to take the moment, so I will spend some time talking about the distance before we start calculating to complete the whole free body diagram in one go, right? If that is 70 centimeters, right? Then that angle is 60 degrees, which means that distance there must be 70 cosine 60 degree, the unit of course centimeter, right? And that one there would be 70 sine 60 degree centimeter. Okay, and the weight, right? Again, the weight is 20 kilonewton. Equal this, but what does it mean? It means it go halfway, right? Therefore, there is another force going in the middle. In the middle, I have to say that one is 20 kilonewton. What does it mean by in the middle, right? It means that it only have there. If that is 70 cosine 60, that is only 35 cosine 60 centimeter. Okay, that one to there. Now, we will need some space here to calculate. So I will remove this part out so we can use the rest of the board.